Your second assignment is all about like terms, and so that's where we will begin. And in this first video, we'll mainly be concerned with the definitions that you're going to need in this assignment, and afterwards we will take a look at some application problems. Our first definition is the definition of the most key term in this whole assignment, and that is like terms. So like terms are terms that have the same letter part, the same variable. So for example, if you have 2x as one term and 3x as another term, they have the same variable, the same letter part, x. And so these guys would be considered like terms. If I had, for example, 7x and 3y, well, they have different variables. These are not like terms. Let's take a look at another example. So consider this expression. It's a pretty long expression. And what you're asked here is to identify what the like terms are. Now, before we talk about that, let me get a little bit more specific with what we mean by the word term. Term is simply the part of the expression that we are adding, right? So here we're adding a whole bunch of stuff. We're adding 14x, negative 2y, xy, negative 3x, 8xy, negative 3. All of these are terms. Notice the sign gets attached to the term. So if you are adding an xy, that's a positive xy. If you were subtracting a 2y, the term is negative 2y. So all of these guys are terms, and what we want is to identify which of these terms are like terms. In other words, which of these terms have the same letter part. And you can see here that 14x and negative 3x both have x as their variable. It's the same. Also, xy and 8xy are also like terms because xy is the same letter part for both terms. Notice that, for example, these guys are not like terms. They both have a y, but their letter parts aren't exactly the same because this term also has an x while the first term does not. So that's what we mean by like terms. In the future video, you're going to see why we care whether terms are like terms or not, why we care that they have the same variable. But for now, we're just focused on, can we identify which of the terms are like terms? Okay. The other definition that I want you to be familiar with is coefficient. Now, a coefficient is the name that we give the number that multiplies the variable part of a term, right? The number. So for example, if I have a term 3x, x is my variable, 3 is the coefficient. It's the number that we multiply by the variable part of the term. All right. Let's see if we can identify some coefficients in the next example. And let's see. So in the first term, our coefficient is 7 because that's what's multiplying the variable part, the x to the 4th. Notice the 4 is not a coefficient because the 4 isn't multiplying the variable part. It just indicates that the x should be raised to that power. So our first coefficient is 7. Our next coefficient is -2. Notice that the sign gets attached to the coefficient. Now, this third term's a little bit tricky. There is no number in front of the variable. But of course, just because there's no number doesn't mean we couldn't put a 1 in here, because remember, multiplying by 1 doesn't change the value of the coefficient. So if you don't see a number, you can just say that the coefficient of that term is 1. The next coefficient is 2/10. And this last one, this term doesn't have a variable part. It actually has a special name. It will be useful for you if you study algebra further. So I'll just mention it here. It's called the constant coefficient. It's the coefficient that doesn't have a variable attached to it, but technically it's still considered a coefficient. So our last coefficient is -11. Okay, so that's the basic terminology, and we're going to build on that in the next video.